Okay, so let's move on to the problem 50. And for this one, I just draw some pictures first because it takes a while to draw these pictures. So in the school, okay, the problem is in the school, we have 300 tickets to sell. And the ticket will be sold either to the students or the teacher, and they charge students $5 and the teacher $6 for each ticket. And we wish the ratio of the students is less than 5 to the teacher is less than 5 but greater or equal than 2. So that's why the number of students is greater or equal than 2 of the teachers and less than or equal 5 of the teachers. So we have 110 seats here, and each seat can sit either 3 students or the 2 teachers. So we need the number of students divided by 3 plus the number of the teachers divided by 2 should be less or equal than the seats capacity we have. Okay. So now let's make the 1, 2, 3 on the graph. So first, this one. Okay, this line is x plus y is less or equal than 300. Okay. And this line is y equals 5x. This line is y equals 2x. Okay. And this line is y over 3 plus x over 2 is less or equal than 110. So now you can see there is a region here, right? So for this region, let's highlight this region. So should be less than this, right? To here, to here, to here. Okay, so this is the region. This is the region we need. Okay. So we try to maximize our dollar, right? So we try to maximize the 5x, 5y plus the 6x equals c, right? We want to see what's this. So in order to see which point we need to parse in, right? So here we have we bounded by this one, this one, this one, and this one, right? We have to see which 4 points parsing this line should have we have the maximum amount of dollars can generate it. Basically, we want to see what's the biggest y-intercept. So now let's see. So we want to maximize this equal to the k. So equal to the 5 is y plus 5 over 6x is equal to 5 times c1, right? So we want to see the maximum of this y plus 6 over 5 of x equals c1. We want to maximize the c1. Okay, so the slope is k is negative 6 over 5 is negative 1.2. Okay, so it's 1.2. So this is the k equals 1, right? This one is k equals negative 1.5, right? So 1.2 is basically in the middle, something like 1.2 is something like this, something in the middle, right? So now let's see. Okay, so either we are here, right? So we are here, we are in this region, right? Or we are here, we're still in the region, right? So to be outside of the region, we need to pass in the point P. When we pass in the point P, this line is only touching the point P and outside this region, and this will give you the will give the maximum value, right? So now we need to solve the point P. The point P is from the x plus y equals 300 and y over 3 plus x over 2 equal 110. So from here we know x over 2 plus y over 2 is 150. So now we can solve is the y over 6 is equal to the 40. So y equals 240, then x equal to the 60. Okay, so we know the point P is 60 and 240. So now we know the max of the C is equal to 5 times the y equals 240 plus 6 times the x is 60, that is equal to 360 plus so this is the maximum of dollars it can generate. Okay, the final question. So find the greatest integer less than this without using the calculator. Okay, so the difficulty is how to deal with the exponent of square root of 3, right? If we are familiar with x over 3, so you know it's the 1.7 square is somewhere greater, just slightly greater than this, or less than 1.8 square, right? Because this is 2.89, this is 3.424. Okay, now let's do this. So we know the square root of 3 is greater than the 1.5 is somewhere close to 1.7 something something. So the 3 should be greater than the 2.3 and should be equal somewhere like this. Okay. So we try to bound it, the exponent first. Okay. Now let's see. So the square root of 3 should be greater or equal than the 2 over 3 or less or equal than 4 over 7. Now let's do the 3 to the square root of 3. I'm sorry. Should be greater than the 3 to the 2 to the 3, less than 3 to the 4 to the 7. So its equivalently is 27 square root 3 square root of 3 or less than it's 8, so it's less than 9. Okay, so now if we can figure out somewhere the integer of this and the integer of this, okay, now we can use the square root of 3 is equal to 1.7 something something, right? And then you can know the square root of 4th is somewhere, because the 1.3 the square is 1.69, right? Okay, so it's 1.3 something something something. Okay, so now we see this one. Okay, so we see the 3 square root of 3 is greater than the 1.7 something is somewhere equal to 5.1 something. Okay, so we know the 3 square root of 3 is greater than the 3 square root of 3 is greater than the 5.1 something something, and is less than 9 over 3 over 4, because we make this small and the fraction become bigger. Okay, denominator becomes small, so 1.3, and then this one is 6.9 something something. Okay, so now we know our target is greater than 5.1 something, less than 6.9 something, right? So basically we know the closest integer is 6, but we need to verify, is this one greater than 6 or less than 6, right? If this one less than 6, so the integer is 5, otherwise it's 6. Okay, now we need to compare. So let's compare versus the 6. Okay, so we can do this one is the 2 times the 3. We can divide by 3 on both sides. Equivalently is 3 minus 1 versus 2. Okay, so this one is 0.7 something, right? Versus the 2. Okay, so how to compare with this, right? We'll only compare with the integer of the powers, right? So basically, let's times 2 is 3.7 point something something versus 2 to the power of 10. This is 2014, right? Okay, so the 7 point something something is greater than the 3 to the 7, right? Is equal to the 729 times 3, of course, is greater than the 1024. So now we know this one is greater than 6, right? And the less than, so 3.3 is greater than 6 and less than 6.9 something something. Okay, so the largest integer less than this number is 6. Okay, that's it for all the challenge problem for chapter 9. Thank you.